Hello everyone and welcoming you to Mojo for Industry exclusive workshop on essential tools for medium voltage electrical assets maintenance powered by Megger India.
Partial discharge is a warning sign of insulation failure. This can also lead to potentially dangerous conditions for substation staff. Megger's PD scan is designed to detect partial discharges to identify faulty equipment before it fails. With its 6 independent and unique sensors, this handheld device is the best for helping you find PD faults quickly and easily. Whether you're working in high or medium voltage substations, to help you find PD faults efficiently, it has acoustic, TEV, and HFCT sensors. Furthermore, the PD scan automatically interprets the data, can perform temperature and humidity measurement, has an integrated camera for reference photos, a QR code scanner, and even wireless headphones. There is also an intuitive simulation box available to assist you with training. Survey your substation for partial discharge and avoid faults before they become failures. Megger's PD scan won't let you down. Megger, helping you to keep the power on.
Electricity generation, transmission, and distribution equipment are designed to provide safe, efficient, and reliable power when properly maintained. One of the main reasons of failure of an electrical asset is the poor or lack of maintenance. Therefore, maintenance of critical asset is an essential part to achieve safety, efficiency, and reliability in power supply network. Today, we are joined by Mr. Jaise Mathew, who is the product specialist at Megger. He will help you to understand the details on importance of predictive maintenance, partial discharge testing, and different reasons for failures in medium voltage electrical assets. Welcome, Mr. Mathew, and thanks for joining us today. So, Mr. Mathew, before you start with your presentation, can you explain why maintenance of electrical assets is critical, especially for medium voltage ones? I think that will help us to set the tone of the session.
As per the question and as per the standards which we follow, mainly IEEE states that in the 3006 standard, in the table, it states that 32% of the failures in the electrical assets are due to the inadequate maintenance work which are done on the electrical assets. So they have categorized the different types of electrical assets and the percentage of failures on the electrical assets because of the inadequate maintenance work. So throughout the session, we will be seeing the standards, what are the types of faults which occur in the electrical assets due to poor maintenance, and how industry is moving forward from a reactive maintenance to a predictive maintenance program. So today's agenda for our session is we will be studying how the maintenance system has upgraded from a reactive to a predictive, and what are the different reasons for the failures in the medium voltage electrical assets and the different types of assets, which are the tools which conventionally we are using to do a preventive maintenance, and which are the advanced tools available nowadays and which industry is keen to understand and to use to have a condition-based maintenance work. And we will be doing a little session on a cable identification, which is one of a tool to identify the target cable from among the bunch of cables, a very good maintenance tool in all the aspects, that is whether it's a reactive or preventive or predictive. And we will be studying a partial discharge testing, a technology which is very much accepted by the market and the industry, and there are a lot of advancements which are come up in the partial discharge testing. And finally, we will be putting up a question like whether an offline test maintenance work is preferred or an online maintenance test is preferred. So moving forward, IEEE Gold Book Table 36 states that the electrical assets, say transformer, circuit breaker, or cables, etc., all types of electrical assets face a failure majorly due to an insulation failure in their electrical assets. The table detailedly tells that 84% of the failures in the transformers are due to the insulation failures. Transformer, as you all are aware that the transformers are the heart of the substation. So to maintain a good healthiness of the transformer, we should have an good strategic plan to do a maintenance on a timely basis, on a condition based basis. Yeah, circuit breakers also face failures, and 21% of failures are due to the insulation failures in the circuit breakers. Cables, which are a major part of electrical assets because they are responsible for the transmission of electricity from a place to another place. And 90% of the cable failures are due to the insulation failures in their components. And so it's very important that we do an periodic monitoring of the insulation. So the failure rate graph is like a bathtub curve. That means whenever an electrical asset is put into service at the first time, there can be a large failure rate. It may be due to an human error, or it may be due to a low quality material used in the manufacturing of that particular electrical assets. However, at the starting point, by doing a good preventive maintenance or by doing a good testing before putting that electrical asset into the service, we can avoid many of the failures and ensure that particular electrical asset is healthy enough when it is put into service. However, when it is put into service along its life period, as you see, the failure rate is constant. That means once all the possible failures are rectified and the electrical asset is put into service, the failure rate is maintained at a constant level. However, every asset has its own life cycle. It is designed for a particular life cycle. As of now, in the era we are living, there is no particular asset that it will live or give the reliability output for an unlimited time period. However, every electrical asset has its own life period, and until it approaches its last life period time, the failure rate increases, as you see in the later part of the failure rate graph. So as its life period is coming to the end, the failure rate increases, and it's very important that we do a very much good maintenance work on that particular asset so that that electrical asset is used maximum to the life cycle with higher reliability. So there are different maintenance strategies followed by the industry. Conventionally, we used to have a reactive maintenance. That means whenever an electrical asset fails, we will carry out the maintenance work to put the electrical asset back into service, to identify the faults which may have caused and rectify the faults, and again put the particular electrical asset into service. However, industry has well accepted that concept of preventive maintenance. That means to have an maintenance work or actions based on a periodic manner or machine run based schedule, and to detect or understand the degradation of that electrical asset and do the needful actions on that particular asset, that so that that particular asset can be used for the designed life cycle and also can be used in a reliable manner. The modern maintenance strategy follows a prediction based maintenance, that is condition based maintenance, which will help us to identify the current functional state or the status of the electrical asset and can plan a preventive maintenance on that particular asset depending upon the current situation of the electrical asset. A predictive maintenance can be done in online condition without putting off your electrical asset, because putting off the electrical asset or taking a shutdown is a very tough job. That means you need to have you are putting a particular electrical asset, that means it can affect your complete output of the substation or the utility. So there are different tools which are available in the industry to carry out the maintenance work from reactive to predictive. The basic test or the tool which is available and we conventionally use is an insulation resistance test. Carried out in the offline condition, your electrical asset is to be put shut down and this particular DC voltage is injected into the DUT and the IR value is calculated or measured. However, This will help you to identify the cause of failure only at a later stage. That means if your electrical asset is already failed, the IR value will indicate you that there is a deterioration. However, if your electrical asset is not failed, that means your IR value will be higher, and it will indicate you that your system or your electrical asset is healthy, and it will not help you to identify or predict any failures in the coming time period. After doing an IR test, many of the utilities carry out a withstand test on that particular asset to understand whether that particular asset is healthy enough to withstand the rated parameters like current or voltage. So in a source, maybe a AC source or DC source is used to do a withstand test, and it is the electrical asset is tested with at least 1 times of that rated voltage, or as per standards it may go to 2 times of the rated voltage on that particular asset. If your electrical asset is healthier, yeah, it should sustain. However, if your electrical asset is not healthy, that means it would not sustain that rated voltage or current. However, this withstand test is also carried out in an offline condition. So both this test will help you to ensure that there is a fault. However, it will not help you to predict that there can be a fault in the future. Nowadays, there is a trend of using a tan delta measurement on the electrical assets. So what does a tan delta measurement does? It injects an AC voltage. As we have seen the IR test and the withstand test, a DC source is used. However, in the tan delta measurement, an AC source is used, yes, which will help to do a testing in the actual condition of that particular asset. That means many of our electrical assets work on AC conditions. So tan delta measurement is carried out in an AC test voltage, and the values of the tan delta measurement will help us to understand whether your electrical asset is deteriorated or not. Asset, for example, transformer, there is some moisturization or any deterioration in that particular asset, and you can do more of the investigation on that particular assets where you have a high tan delta value above the threshold limits which are set by the different standards for different electrical assets. However, it will not predict or it will not help you to understand that that particular asset is deteriorated in the online condition. Tan delta measurement is one of the offline preventive maintenance tests. Some of the industry experts say that we can identify the deterioration in the electrical assets by doing a thermography. Thermography is a principle in which the thermographic cameras are based on the infrared technology. It will give you the temperature of the surface of the target object, and if there is any deterioration in the electrical asset and which has led to heat up of the target object, it will give you a temperature profile which will help you to understand that there is a high heat radiated from that particular asset. However, this high heat energy is radiated only at a later stage of deterioration. So nowadays there is a trend of using partial discharge survey on that electrical assets, which will help you to identify or detect some of the discharges in the online conditions. And from the outside of the panel, you are detecting the different types of discharges which are emitted from the internal components of your electrical assets like medium voltage switchgear panels or transformers, etc. So PD survey is a new tool came into the market which is very well accepted, and many of the industries are looking forward and using this survey tool to do a predictive maintenance and understand the condition of the electrical asset. So what are the different types of partial discharges? We can see corona discharges in the switch yards on the transmission lines in the air, as you can hear some sounds because of corona discharges, and it can be visible with our human eye. At the surfaces of different materials, surface discharges can lead to partial discharge. Delaminated discharges Because of low quality material, it can lead to voids or internal discharges in the dielectric material. Due to loose connection, there can be sparks, and which can lead to discharges at terminations. Also, electrical tree, a phenomenon which is seen in the porcelain material and in the cables, which can increase the aging of a particular asset if it's unattended. And aging means, that means if the life cycle which is designed for that particular asset can get lessened, and it can get aged, and it should be replaced before the life cycle which is designed for. But however, if we are doing a condition based monitoring, we can use particular electrical assets to their maximum life cycle and also to a higher life period with higher reliability. And so we will see how different detection methods are available to detect the partial discharges with different characteristics. So if the PDs are emitting a light, human eye can identify it. If there is chattering sound in the audible range, human ear can sense it. If there is smell because of the burnout, human ear noses can feel it. However, if the PDs are emitting signals in the acoustic range which are out of the range of the human audible range, that means 20 to 100 kilohertz, different sensors can be used, acoustic sensors, to sense that particular range frequencies and identify the effect of a PDs and the intensity of the PDs and the particular asset. Ultrasound, also different sensors available. Optical spectrum, as we said, there are different cameras which are available, but as I said, the temperature increases at a later stage. But if you want to find out a partial discharges at an earlier stage, we need to have different sensors and different equipments with a single tool, so that you have all the tools on a single device and you are scanning that particular electrical asset from different angles and seeing whether there is a PD in different frequency ranges. In the radio spectrum, conventionally PD measurements are done with the help of coupling capacitor, which is as per the standard regulations how the testing methods have to be done. However, inductive coupling can be done with the help of high frequency current transformers. Capacitive coupling can be done on using the transient and voltage sensors on the switchgear panels, and also ultra high frequency PDM measurements are also recommended to identify the PD activity in the electrical assets in the utility. So different characteristics of PD needs a different types of sensors to identify it. So when to do which, there is a strategic manner for the maintenance. Once a particular asset, before putting the particular asset into service, at the installation time, an offline measurement can be done and ensure that there is no discharges in that particular asset. Once the particular asset is put into service, online PD detection can be done to understand the condition of that particular asset and identify whether it's deteriorating or not. And once it is approaching its life cycle end, we can take shutdown and do the offline PD measurements to get the detailed measurements. And if there is any particular components in that particular assets which is highly degraded, you can just replace or repair it. This will help us to use that particular asset for a maximum life period which is designed for. This is the test method which is defined by IEC 60270. There should be a high voltage source. There should be a coupling capacitor between your DUT and a device is used, centralized device is used to analyze the readings and to identify whether there is PD and which type of PD is generated by doing analysis of the PRPD pattern, which is phase resolved partial discharge pattern. Some of you may think, is there any threshold value for the partial discharges? Up till now, there are no standards, but we can carry out a condition based or maintenance on that particular assets. If you have a number of panels, you can measure on all the panels and you can maintain a level for the threshold, asset threshold level for the PD activity, and you can carry out a regular monitoring on the particular assets. So using TV sensor on the medium voltage switchgear panels, you can carry out very easily and identify that particular switchgear panel which is generating or emitting the PDs. HFCTs can be used at the cable terminations, which will help you to identify from among the number of cable terminations or the cables, which one is a suspected one. And you can go for an offline or shutdown of that particular cable and do an offline PD measurement to localize the weak spots along the length of the cable. So online PD detection is very well used and very well accepted. On different particular electrical assets, there are different sensors which are used. However, if you want to do a detailed analysis of the discharges, ultra high frequency technique is used nowadays with a wider frequency range to understand at which particular frequency if there is a minute discharge happening. And that particular frequency is converted into the time domain to get a PRPD pattern, which will help you to identify the cause or which type of PD is that, and which also will help if there is an actual PD. You can just convert that pattern into a PD level and understand the intensity of the PD. There are some case studies in the coming slides, which Megger factory has carried out on different industries. This is an online PD measurement on the ring main units. There was a failure and they decided to carry out the online PD detection, and on doing an online PD detection using the acoustic sensor, it was found that there is a defective PT potential transformer which had white patches because of the discharges, and it was because of the aging of the isolating surface. And in the complete substation, the investigation was done and the severely damaged or aged BTs or PTs were identified and preventively replaced so that a future faults can be avoided. This case study is based on a solar power plant where a number of power cables were taken into shutdown, and in pre-planned predictive maintenance was carried out, and a tan delta measurement was done, and also partial discharge measurement was done. And in one of the cable, it was identified that there is discharge at about 800 meters along the length of the 1 kilometer cable from the test end, and it was reconfirmed by doing the testing from the other end, and that particular location was again confirmed by doing the test from the other end. And the utility decided to do an excavation at that particular spot at that 800 meters from the test end, first test end, and 200 meters from the other end. Same location was excavated and a joint was found which was these white patches which was deteriorated. And by doing a planned shutdown, as it's a solar power plant, they have a shutdown in the night time, and the testing was done at the night time. They could avoid a major failure which could have occurred in the service period.
Mr. Mathew, there are a couple of audience who want to ask you questions live. So can I take them live at least?
Yeah.
Dr. Rath, you can ask your questions and you can give a brief introduction of yourself as well.
Sir, exactly the little bit suggestion is required here. If you were going with any machinery or component machinery or in the EV electrical vehicle system, right? So what is the regular conditions for the monitoring as well as the maintenance for that cables? Is it necessary that within a certain kilometer wise the movement, or it depends upon the time period?
So in the cable, as we have discussed, there is reactive maintenance, a preventive maintenance, and a predictive maintenance. So once your cable is coming to your site, the cable will be in a segment of 500 meters. So there is always jointing done to increase the length of the cable, and before putting the cable into service, there is terminations which are done on both the ends of the cables. So when a cable is put into installation and before putting the cable into service, it is very well recommended that you do a PD measurement to ensure whether the joints and terminations are healthy. Also, if it's an XLP type of cable, a VLF withstand test is recommended to ensure if there is any weak points along the length of the cable, it would get faulty and repair before putting a cable into service, so that you can avoid many of the faults which can be occurred in the service time. Once your cable is put into service, along the period of time, to understand the healthiness of the cable, as a preventive maintenance, you can do the tan delta measurement to understand the healthiness of the dielectric material, as well as partial discharge diagnosis can be done to identify whether there is any weak points or any joints has become weak along the length of the cable. And if yes, it is deteriorated and it's localized, you can just repair that particular joint. And before putting the cable into service, either you can do a PDE test or do also VLF withstand test to ensure that your cable is healthy when it is put into service. So these are the different tests to do the maintenance on the cables.
I think Dr. Rath, your question is addressed. Thank you so much for participating. And there are many questions in Q&A box itself. There's a question from Mr. Vinay Vishwakarma. Will you please tell how a Megger test on solar module to confirm their insulation quality?
Every electrical assets in the solar plants will have a particular rating, and their data sheet will be giving, the manufacturers will be giving a data sheet which will indicate the rated IR values or the rated operating voltage and all. So by doing an IR test or Megger test, you can ensure that your electrical asset is healthy as a reactive maintenance. Also, if there is any particular asset which has that particular rated voltage, by doing a withstand test to that particular asset will help you to ensure that when that particular electrical asset is put into service, whether it's healthy enough to withstand that particular rated operating voltage. If when it is put into service, there are different electrical assets which are in the solar power plant. So there are different tools to do a predictive or preventive maintenance on different electrical assets, depending upon the type of electrical assets you are looking forward in that particular solar power plant.
Interesting. One more question related to solar only. This question is from Mr. Ajat Kumar. In solar plant, what things we have to consider before testing partial discharge?
Plants, if you're looking for a cable, solar power plants has a positive way because they have the shutdowns in the evening or the night times. So doing an offline PD measurement is possible in the solar power plants because of this. And this testing offline measurements can be done on the electrical assets in the night times. Depending upon the type of electrical assets, different sources can be used. If you're looking for cables, as per the standards, IEEE 400.2 recommends a very low frequency source to be used because AC source cannot be used because it's very bulky. There are standards like IEEE 400.2 and IEEE 400.4, which suggests VLF source, which is very low frequency, AC source, which have a frequency of 0.01 Hertz to 0.1 Hertz. However, if you want to compare the partial discharge results with the manufacturer results, you can use a DAC source, which is damped alternating current source, for testing the partial discharges in cables. On the other electrical assets, yeah, you can use the online PD detection methods.
Again, I'll take quick one question from Mr. Armugam. It's asking that how to measure underground cable fault.
In the underground cable faults, there are different methods used, different techniques used. One of the very well accepted and very result proven method is the arc reflection multi-shot method, in which a principle called time domain reflectiometry is used. Like it's very similar to the radar principle in the aerospace. A signal is emitted with known velocity into the cable under test, and wherever there is a change in impedance throughout the length of the cable, the signal gets reflected back to the test end, and a graph is shown on the display of the testing equipment, which will help you to pre-locate or understand the approximate distance at which the fault can be. Once you understood that at this particular approximate distance you have a fault, you can go for the technique called thumping or surging, in which you will actually pinpoint your fault. And for this, you need to have a testing equipment with all the different techniques, because cable fault is a tedious job if you are not having a tool with all capabilities. Every cable faults have different natures, and depending upon the nature, there can be different techniques which can be used. And in practice, there is ARM method, arc reflection method, current impulse method, voltage decay method to identify high breakdown voltage faults, ICE method for the moisturized faults. And if there is a highly resistive fault, and if you want to convert the fault into low resistive so that you can get the picture or the graph, burning method, which is not recommended. However, if you want to find the fault at any cost, burning can be used. So there are different techniques used in the market, and Megger has a solution for that.
There's a question related to the shutdown, whether we require to do the shutdown, where we need to do the partial discharge measurement. So if you can answer that as well.
In the as we have seen, the online PD detection, which is the unconventional method, is done in the service condition. That means you need not take a shutdown. We are using different sensors. If you're looking for the PD detection on switchgear panels, you can use the acoustic sensors and the TEV sensors. If you're looking for the underground cables, you can use the HFCTs in the online condition, which will be clamped on the armor of the cable terminations. And acoustic sensors and UHF sensors can be used to identify or detect the PDs in the transformers and the GIS substations in online condition.
So far, and this question is related to thermography again, because there is a kind of no common perception that thermography is enough to detect failures, and there's a question related to that. Would you like to address that question as well?
Yeah, as we have said, we are moving from a reactive maintenance to predictive maintenance. Thermographic cameras will give you only the temperature profile. That means if there is a hot spot in the transmission lines or any contacts, it will detect you. However, if you want to do a predictive maintenance or condition-based maintenance, you need to identify the deterioration at an earlier stage, which would not be detected by the thermographic cameras. So partial discharge comes into picture when you are moving from the reactive or preventive maintenance to a predictive maintenance.
So this question was related to the safety, that what safety procedures do you put in place when conducting routine maintenance?
Routine tests, we need to follow that safety precautions which are laid out by different organizations, have different level of safety precautions. Aspect or the first level of safety, you need to have all the different safety PPs available with the operator before doing any particular maintenance work on any of the electrical assets. And also, it's very well recommended that even if you're doing offline PD measurements or any cable or any assets, before doing a second round of test, you need to make sure that particular electrical asset is discharged completely with the help of discharge rods.
So thank you again, Mr. Mathew, for answering those questions. And before concluding today's session, it would be great if you can just share your concluding remarks. No?
Thank you, Mojo Industry, for organizing this session and all the participants for your valuable time. We, as a Megger, giving a complete solution for each and every electrical asset monitoring. So if you have a circuit breaker, there are preventive maintenance test equipments for the circuit breaker. If you have in transformer, we have a number of say 9 to 10 equipments to test the different components of the transformers. If you say relay, yes, we have smart testing equipments. If you say cable, yes, we have the cable fault locating as well as predictive cable diagnostic equipments. So to test any of the electrical assets in your utility industry, we would be very happy to help you out. If you have any of the difficulties in the reactive, preventive, or predictive maintenance, please you can mail to the mail ID shown on the display, and we would be very happy to help you out in the coming days. Thank you so much.
So that's great, Mr. Mathew. It was my pleasure having you here today. So this concludes the workshop on essential tools for medium voltage electrical assets maintenance powered by Megger India. We hope to see you again. Till then, take care and stay safe.
For more updates, please subscribe to our YouTube channel and press the bell icon.